Hi guys, my name is Edward, and welcome to the second tutorial of creating a Flappy build game with Godot. And before jumping into the editor, I want to show you something that you can do in the project manager. And once you have a few projects, let's say because you have been playing with the engine, and you have done a lot of test projects, or you just have been using it for a while, your project list is going to get long. So to keep your favorite projects always on top of the list, you can mark the star that is on the left of your project, and it will be showed above the others without the star marked. Having said that, let's jump into the tutorial. So if you're picking the project from where we left off in the previous video, this is how the editor is going to look like. And taking a look at the file system panel, you'll see that this is showing us two categories, favorites and res. The favorites is going to show us those folders that we marked as favorite, and the res, which stands for resource, shows us all the folders and resources that we have created so far. I don't use the favorite that much, so as soon as I open the editor I always jump into the resources. And if you wonder what is the scene that we have created in the last video, this is of course in the stage folder. But why this is not being shown when we open the editor? Well, what happened is that the editor won't show the scene that we have opened last time, but the scene that we have set as main scene. And the main scene is the one that shows first when we run our game. I'm going to open the game stage scene, and we have been running it by pressing this button. And what this button does is run the scene that we have currently open. But if I want to run the whole project, we have to press this one. And it's telling me that there is not main scene set yet. I'm going to set it by going to project settings. And in the application section, as the main scene I'm going to set the game stage. Just click on this folder icon, then on file. Select the game stage file and click on open. Let's try to run the whole project again. And there we go. And from now on, every time we open the editor, the game stage is going to show up. So now we're going to create the scene that will be the bird, and I have made some slides to explain and illustrate a few things that we are going to implement in this video. So the bird scene is going to have 4 nodes that are going to take care of different functions. One of them will handle the physics and how the bird moves in the world. Other one will be in charge of the visualization, showing the sprite to the user. The next one will define the shape we're going to use for the collisions. And the last one will manage the animations that we are going to define later. And fortunately Godot comes with nodes that already have all these functions. For the physics we are going to use the rigid body 2D to display the sprites, and animate sprite node, which is basically an array of sprites. For the collisions, a collision shape 2D that will contain the shape that the rigid body will use to handle the collisions. And finally, we are going to use an animation player to define and manage our animations. So back to the editor, I'm going to create a new scene by going to scene, then new scene, and Godot is going to take us to a new empty scene on a new tab, and we can always switch to another scene just by clicking on the tab. So as I said before, this scene will be the bird, and I'm going to add the 4 nodes we are going to be using. I'm going to click on create new node, and I'm going to search for rigid body 2D. I'm using the search box here, but if you are just getting started with Godot, it might be better for you to scroll down and find what you are looking for, so you can familiarize with all the nodes that are available. And also make sure not to select a rigid body for 3D. You can tell between 3D and 2D by looking at the color of the node. Red nodes are for 3D and blue for 2D. Double click on it to add it, and we can see it here in the scene panel. I'm going to add the animated sprite. And you can see that the animated sprite was added as a child of the rigid body. And this is because a scene has to have one main node. And even if you try to save an empty scene, the editor won't allow you to do it without having a main node. And this is actually really convenient, because we want the animated sprite position to be relative to the rigid body. Let's now add the collision shape 2D. and this was added as a child of the animated sprite, because when I created it, I had selected the animated sprite. But we can reparent a node by selecting it, and clicking on Reparent Selected Node. I'm going to set the rigid body as the parent. And now we have the animated sprite and the collision shape as siblings. And the last node is going to be the animation player. And here we can see that the animation editor shows up, but we can close it by pressing the button animation at the bottom. And I personally prefer to rename the main node based on what is the scene for. So I'm going to rename the rigid body to bear. And I also renamed the other nodes, but I'll do it later, because I want to tell you why I named them in that way. I'm going to hit Ctrl S to save the scene. Let's save it in the scenes folder as bear.tscn. And I'm pretty sure that you might have noticed that the inspector panel shows us the properties of the node that we have selected. For instance, in the rigid body, we have the mass, the gravity scale, the linear velocity, and also the position, rotation, and the scale. But for now, let's just focus on the animated sprite, which has a property called frames. And this property is asking us for a resource, sprite frames, which is what will contain our sprites. To create a new one, just press on null, and then new sprite frame. And to edit it, we can either click on the little arrow here, or click on the resource, and then on edit. And we can see that the sprite frame editor shows up. To add our sprites, let's click on load resource, which is a folder icon. And under the sprites folder, I'm going to use the bare orange sprite. And we can have multiple selection by clicking on them while holding Ctrl. Click on open. And now we can see that one of the sprites is being displayed. And to switch to another frame, there is a property on the animated sprites node, name frame, that indicates the index of the sprite being displayed. If I set it to 1, it will show the frame number 1. And the same if I set it to 2. I'm just going to leave it at 0 because the animation player is what is going to be changing this value for the animations. Let's run the scene to see what we got so far. And the bird is a little bit offset, so let's place it somewhere in the middle by dragging it. But when I try to move it, what I have moved is the collision shape. I'm going to hit Ctrl Z to undo it. And we can avoid selecting children of a node by selecting the parent node and then clicking on this icon that makes sure the children are not selectable. I'm going to drag it again. Run the scene, and we can now see better that the bird is falling thanks to the rigid body. So now we're going to make the bird flap when the player hits a key. In the original Flappy bird you have to tap on the screen, but we are going to implement that later. And to do so, we're going to add a script to the bird node by pressing on Create a Script and make sure that you have the bird selected. A window dialog pops up telling us that the script is going to inherit from rigid body 2D, which is the type of the node. The language will be GDScript, and that is the only available so far. And for the path, I'm going to save it in the scripts folder as bear.gd. Click on Create. We can see there is a script attached to this node because there is an icon here. And also the script editor has been opened. We can go back to the scene view by clicking on 2D or on one of the nodes. In the script editor we have this panel at the left that lists the recent script we have been using. I personally never use it, so I'm going to hide it. And Godot has written some code to give us a little hint on how to structure our code. I'm going to delete the comments, and I always write at the very top of the script the name of the script, so I can know on which one I'm working on. This function, ready, It's called when the node is added to the scene, and it's the one we're going to be using to initialize whatever we need to. This keyword pass is a line of code that does nothing, but because GDScript uses indentation to structure the code, when an indentation is required, usually after colon, there have to be at least one line of code. If I erase the keyword pass, it throws me an error, and by adding a line of code, the error goes away. I always leave the pass keyword, even though I have code in the function, but you don't have to do it if you don't want to. Now this function ready is called a callback or virtual function, and a virtual function is a function that we won't be calling ourselves, but the engine will. To see a list of other virtual functions, we can type an underscore, and the autocomplete will display all of them. They have an underscore as prefix, so we can tell between callbacks and the functions we made. I'm going to select the fixed process function, which is called every frame at a fixed rate, making it really convenient to handle physics. Let's print something to see if it is working. And it seems like the function ready is being called, but the fixed process isn't, and that's because we need to enable it by calling the function setFixedProcess and set it as true. Let's give it another try. And now it's working. But we won't be using the fixed process function now. The function we're going to focus on is the input callback. And let's print something in this function to see what happens. And as we did with the fixed process, we also need to enable this callback function, or it won't be called by the engine. To do so, there is a function named setProcessInput. Let's run the scene again. And you can see that as soon as I move the mouse in the window, the function input gets called. And that is because the input function notifies us, not only when the user presses a key, but also when any type of input event happens. When the user moves the mouse, when a button of the mouse is pressed, and even touch events for touch devices. So we need to filter the type of event we are getting, and this variable contains the type of event happening. So we can say if event.type is equal to input event dot, and in this case we're looking for key. Let's see if this is working. And now it only prints when I hit any key, but I only want it to print when I press space. And if the event is a key, it will come with a property named scan code that we can use to know what key is being pressed. So if the event is a key and the scan code property is equal to key space, the exclamation mark will be printed. Let's give it a shot. And I press space only once, but it's printing twice, when I press the key and when I release it. To avoid this, there is a function that tells us if the event is pressed. So besides of this condition, we're going to say and event that is pressed. Let's see if it's working. And it does. Now this line of code is too long, so I'm going to move the first condition apart. But instead of asking if the event is a key, I'll ask if the event is not a key. And if it's so, it's going to return. And this makes sure that all the code we load is going to run only if the event is a key. Let's clean this up. give it another shot. And it's working as before. But if I hold a spacebar, it keeps triggering the event, and I just want it when I have just pressed the key. So we can ask if the event is an echo. In this case, we want to know if it's not. Let's see if it's working. And now, even if I hold the key, it prints only once. And this is pretty good, but let's say that we also want it to work. When we press the F key, we have to ask if the scan code is equal to key space, or if it's equal to key F. And it worked for both keys. But let's say that I want to add more keys or support for a game controller. This will get more complicated. And that is when input mapping becomes very handy, because they allow us to abstract as many keys or buttons as we want to an action, and we can set up the input map of our project in the project settings under the tab Input Map. And Godot has already set a few actions for the user interface. So we are going to create one named Flap. Click on Add, and we can set the keys of the actions by clicking on the plus icon. I'm going to assign the key space and also the key F. You can also assign a game controller button, but I don't have any, so let's go back to the code. And since we are now using actions, I'm going to delete this code. And let's see if the event type we get when pressing space is an action. Let's replace this for action. If it's equals, we're going to print the exclamation mark. Let's give it a try. And it doesn't print anything when I press space or F. Well, that is because we have indeed assigned the F and space to an action, but they are still keys, so they are key types. Now there is a function that allows us to know if an action has been pressed no matter what type it is. So instead of asking if the event type is action, we will say event.isActionPressed and give it the name of the action. Let's see if it's working. Space work and also F. And if I hold the key, it just prints once, and that is really convenient. So now that we have the input up and running, we can make the bell flap. Let's get rid of this print, and instead of implementing the logic of the flap here in the input function, we are going to call a function named flap, and let's create it below the fixed process. So when the bird flaps, what we wanted to do is to go up a little bit, and on a rigid body we have three main functions to manipulate where the bird is going. So instead of explaining them, I think that it's better to see them in action. Those functions are set apply force to apply a force, apply impulse, and set linear velocity. Let's try out the first one, and the gravity makes the bird false. I'm going to apply a force that goes up, and when it is applied, that force starts taking over the gravity. So the bird starts falling, and then it goes up. And also we can see that the velocity is increasing over time. And that is because the force is being applied with an acceleration. And also notice that I have just applied the force once, and it keeps going up. So this is definitely not what we are looking for. The second option is to apply an impulse upwards, and what this does is to suddenly add an impulse to the object, and even happening on an instance, because it's being added, it makes the outcome unpredictable. What I mean is that if the bird is falling very fast, the impulse has to be very strong to go against it, so this one won't do the trick either. The last option is to set the linear velocity of the bird, and by setting the velocity, it doesn't matter if the bird is falling really fast, because we are overriding its current velocity. So this is the perfect one for the game. So back to the editor. In the flap function we are going to set the linear velocity, passing a vector 2. And since we are only interested in the vertical velocity, we are going to set the horizontal velocity as its same value by just saying get linear velocity.x. And for y, I'm going to give it a value of minus 150 because I know it works really well. Let's see if it's working. And when I press space the bear jumps, but it takes it too long to go down. So we're going to increase the gravity by increasing the gravity scale, which is a property we can set on the rigid body in the inspector, and by default is 1. I'll set it as 5. Let's try it again. And now it feels way faster. It might seem a little bit insane, but once we have added more things to the game, it will feel better. So the next step is to rotate the bear, making it look up when it flaps. So in the flap function, we're going to set the angular velocity to minus 3. So it goes counterclockwise. Let's see. And it's difficult to see what is happening with the rotation because the bear is moving. So just for the moment, I'll set the gravity scale to 0 and comment this line so it doesn't go up. Let's try it again now. And we can see that the bear is rotating way too much. So we're gonna have to trick it a little to get a nice outcome. So what is happening is that the bear is rotating until the regular velocity drops to 0. And when we apply an angular velocity of minus 3, the bear reaches 164 degrees. So we're going to set a limit of 30 degrees. So if the rotation is bigger than 30, we are going to set it back to 30. And if I set an angular velocity of minus 3, the bear won't go beyond 30 degrees. But we can see that it is still having an angular velocity until it drops to 0. So besides of setting the rotation to 30, we're also going to set the angular velocity to 0. And now it's working as expected. So back to the code. In the fixed process function, we will say if get rotation is bigger than 30, set rotation to 30. And because Godot works with radians, we need to convert these degrees to radians. And there is a function named degrees to radians. And on this one will be the opposite. Radians to degrees. Let's try it out. And there we go. Now we also want the bear to face down when it's falling. And we can know when the bear is falling if the linear velocity, the vertical one, is bigger than 0. And if it's so, we're going to set the angular velocity to 1.5. This value is positive, so it goes clockwise. Let's give it a shot. And of course, we need to get rid of this and set the gravity scale back to 5. Let's run the scene. And now when I press space or F, it faces up. And when it's falling, it faces down. Well, that's gonna be it for now. I hope you guys have learned from this video. I really enjoy making it, and this tutorial is going to get even more interesting. So subscribe for future videos, and until next time, see you later.